This video is about key characteristics of quadratic functions. These same rules will apply to every type of function, but we're specifically talking about quadratics in this video. By key characteristics, I just mean important characteristics, things that you might want to know if your parabola is the trip that a rocket is taking. It's important to know, like, where did it start? What was its maximum height? When did it hit the ground? So that kind of thing. There's only really two new things here that are new for this unit anyway, that we didn't talk about with lines in the last unit. The minimum and maximum, it's going to be an either or. It's either got a minimum like this or a maximum like this. And that's the vertex. And sometimes we call those extrema. It just means like the extreme points, either the tallest or the lowest. And then axis of symmetry, which we'll get to in a second. The rest you've definitely seen. These are new in this unit as well, but the rest you've kind of seen before. So we'll go through each one, just kind of looking at some graphs and identifying these characteristics. So the vertex point is the corner of your graph. It's either the bottom of the bowl or the top of the hill. And so we would label it as either a minimum, which in this point it's a minimum because it's a low point, or a maximum if it's the top of the hill because it's a high point. We've talked in past videos about how to find the vertex, so if you need to go back and watch those, you can. If it's in vertex form, it's literally just HK. If it's in standard form, you use the formula -b over 2a if you remember that. Okay, so let's go through a few. Here's the vertex, 2, 1. Is this a maximum or a minimum? At this point, it is a minimum because it's the bottom. This one's also a minimum because it's at the bottom. This one is a maximum. It's at the top of the hill. It's as simple as that. All right, let's talk about axis of symmetry. The axis of symmetry is, when we talk about an axis, we just mean like a line that usually you revolve around or something like that. Symmetry means it's the same on both sides. So this is a line that goes straight through the parabola, where if you were to flip the parabola across that line, you'd get the same thing. Parabolas are very symmetrical, and so they have this axis of symmetry that goes right down the middle of the parabola. It always goes through the vertex. It has to. And if you remember, a vertical line, the equation for a vertical line always looks like x equals, and then whatever that x value is. Because this is the point 2, 0, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5. It's the equation x equals 2 because x does always equal 2, no matter what y is. So to find the axis of symmetry, it's very easy. It's always x equals, and then whatever the x coordinate of your vertex is. So that's called h if you remember. And I remember that comes from the vertex. Like on this one, it goes through -2. So the equation for this line is x equals -2. For this one, it goes through +2 again. So it's x equals 2. That's the axis of symmetry.
Teachers, at this time, you may dismiss your car drivers.
We're going to get interrupted a lot, sorry.
Car drivers as well as boys and girls basketball players.
All right, zeros we've talked about before plenty of times. Remember, the zeros are just where it hits the x-axis. Though literally where the output is 0. Those are also called roots, and they're also just the solutions to your equation. This one does not have any because it doesn't hit the x-axis. Y-axis doesn't count. So this is none. This one has 2 zeros. Looks like about -4.5 and about 0.4 or 0.5. I can't tell exactly what that is. This is a bad graph, but something like that would be the zeros there. And this one has one that looks like at 0 and one at 4. The y-intercept doesn't get a special name, it's just the y-intercept. As always, that's where it hits the y-axis. So on this one, the y-intercept is 5. On this one, the y-intercept is -1. And on this one, the y-intercept looks like it's -1. If you want to put the full coordinate, you can, like 0, -1, or 0, 5. It means the same thing. Okay, let's talk domain and range. Remember, domain is all the x values in your function that you could possibly hit. Range is all the y values. So let's look at this first one. If I'm looking at the x values, it hits at 2 and 3 and 4 and 5 and 6. It goes on forever.
At this time, you may dismiss your car riders. Car riders at this time.
It also goes to the left forever. It goes to 1, 0, -1. It has arrows on the end, meaning it keeps going that way and it keeps going this way forever. So I don't know about you, but I don't want to write out all the numbers in the world. So I'm just going to say all real numbers. That's the domain. And another way of writing that is, if you remember, a big R with a line through it. This stands for all real numbers. You could also write this in interval notation by saying -infinity to infinity. From -infinity to infinity, everything is in the domain. There's nothing that doesn't count. And so any of these things works for the domain. That will be the case for these as well. In fact, any quadratic goes left forever and right forever. This goes left forever and right forever. It's going to get really steep, but it keeps going. There's no number that I couldn't plug in. So for each of these, the domain is all real numbers. The only time that wouldn't happen is if there was an endpoint. You could also say -infinity to infinity. Okay, for the range is a little different on quadratics. Because notice that this parabola has a y value at 6 and 5 and 4 and 3 and 2 and 1, but anything below 1, this doesn't actually exist anymore. It's not possible for me to get any y values down here. I can only get y values that are 1 or greater. And so for the range, we only want numbers that are from 1 to infinity. And that is including 1 because it does hit right at 1, and we use a parenthesis around infinity. So the range is only from 1 and up. It doesn't exist below that. Another way of writing this would be set notation. You could just say y has to be greater than or equal to 1. It's always going to happen at the vertex. Like in this one, the graph goes up forever, but as I come down, looking at the y values, it doesn't exist below -3. So for this one, the range is from -3 to infinity. Again, it does include -3 because I hit right at -3, but not below it. On this one, it doesn't go up, it goes down forever, but then it doesn't go past 7. And so this one only goes from 7 to -infinity. It doesn't go above 7. We always, when we write intervals, put the smallest number first. So rather than say 7 to -infinity, I'll say -infinity to 7. Again, we do include the 7 because it does hit 7. All right, let's talk about a few other intervals. And this one I want to know, where does it increase and where does it decrease? So with lines are always increasing.
All right, we have wave 1 of vertices. That's 38,
Sorry, guys.
13, 10, 81, 77, 8, 122, 87, 44, 6, 121, and 60. Repeating those vertices, 38, 13, 10, 81, 121, and 60. Don't forget to get your food when you leave.
Okay, so lines are either always increasing or always decreasing, but that's not the case with a parabola. Just to remind you, increasing means like as you read the graph from left to right, just like you read words from left to right. So as you read it from left to right, where are you going uphill, increasing, versus going downhill, decreasing? Let's start with this first one. If I was on a bike and I was coming down this, that would be very steep. I would be going downhill, 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 up until this point. And then right there at the vertex, it switches. At the vertex, I am neither increasing nor decreasing, and then from then on out, I'm increasing, I'm going uphill. So the way we say these intervals is, it starts off by decreasing, and that interval is from negative, is this entire thing up until the vertex. We write intervals using x values so that I don't have to use a ton of words and be like, from the left to the vertex. So we write it with the x values. It's from negative infinity up until the x value of 2. So from negative infinity to 2. It's decreasing. And then from then on, it's increasing. So it's increasing from 2 to positive infinity, from 2 on. We use parentheses, not a bracket, because technically that point is not included. It's neither increasing nor decreasing. Let's try another one. This one again starts off as decreasing until that vertex point, then it's increasing. And again, we use the x coordinates to talk about these. So it's decreasing from negative infinity up until here, which is an x coordinate of negative 2. So from negative infinity to negative 2. Then it's increasing from negative 2 to infinity. Last one, this one starts off increasing. So its interval of increase is from negative infinity, xy's, up until this point. So from negative infinity to here. It's tempting to be like, from negative infinity to 7, but that's the y coordinate. We're using the x's. So in x land, it's 2. And then from 2 to infinity, it's decreasing. So from 2 to infinity, it's decreasing. Again, that's because it's x coordinates. So from 2 and then going up.
Last call for wave 1, votes 38, 13, 10, 81, 77, 8, 122, 87, 44, 6, 121, and 60. Last call.
Okay, so let's talk about one other type of interval, and that's where the graph is positive or negative. This is different from increasing and decreasing. Positive means it's above the x-axis. And negative means below the x-axis. It means like positive output values. The y values are positive, the y values are negative. I like to think of this as like above ground versus below ground. Like above sea level versus a negative or below sea level. This is important for things like stock graphs. You want to know if you're in the negative.
Sanaya Davis, please come to the service window. Sanaya Davis, please come to the service window.
So this first one's easy. This first one never goes below the x-axis. It never goes below ground, if you will. So this one is entirely positive. You could just say it's all positive. You could say it's positive for all real numbers, or from negative infinity to infinity. And for negative, that one doesn't really apply. NA, not applicable, does not apply. Don't even really need to put that one. This one, it starts off positive, positive, positive. It's above the x-axis until here. That's when we go below ground, we're below the x-axis until here. Like imagine this is the ground. So it's positive, negative, positive. There's actually 3 separate intervals here. Let's start with this negative part. So it's negative from here to here. Again, I'm using the x coordinates, so that's from negative 4.5 to about 0.5. I'm using parentheses, not brackets, because I'm not including those points. They're right in between, so they don't really count. Okay, it's positive right here, which, if I'm using the x coordinates, is from negative infinity up until negative 4.5. It's also positive from 0.5 to infinity. So both of these are positive intervals. You can connect them, just write them together. You can write a comma in between. Sometimes we even put u to represent the union of those two.
Way 2, we have both 50, 19, and 118. Repeating those vertices, 50, 19, and 118.
All right, this one jumps back and forth as well. It starts off negative below the x-axis, then it's positive for this whole section, and then it's negative again. So it's negative from negative infinity up until 0. So from negative infinity to 0, and then also from 4 on. So from 4 to infinity. I know it feels like it should be 4 to negative infinity because it's going down, but it's 4 to positive infinity if we're using the x values. It's positive up here from 0 to 4. Everything that exists from the x value 0 to 4 is positive. All right, the very last thing we're going to talk about is the end behavior. The end behavior literally just means what is happening at the ends of the graph. Is it going up? Is it going down? For quadratic, they're always going to be doing the same thing. Remember, end behavior always looks like this. As x approaches infinity, y approaches something, fill in the blank. And then as x approaches negative infinity, y approaches
Teachers, at this time you may dismiss your remaining students to the cafeteria. Dismiss your remaining students to the cafeteria.
Hopefully those will stop now, sorry. Okay, this right here, as x approaches infinity, oh my gosh. As x approaches infinity.
Let's call for way 2. We have both 50, 19, and 118.
Okay. As x approaches infinity just means as we go this way, because x approaches infinity this direction. So this is just saying what's happening in the right side of your graph. And as x approaches negative infinity is that way. So it's just saying what's happening on the left side of your graph. On this first one, both of them are going up to infinity. So I would say as x approaches infinity, so as we go this way, it's going up. So y approaches infinity. And as x approaches negative infinity, so as we go this way and look at the left end of the graph, it's also going up. So y approaches infinity. They're both going up to infinity. This one's going to be the exact same. Both ends are going up to infinity. So this one would be the exact same end behavior. And this one would be the opposite. On this one, both ends are coming down. So it would be the same, but negatives. As x approaches infinity, y approaches. So like as we go to the right, it's going down. So y approaches negative infinity. And as x approaches negative infinity, so as we go that way, it's also going down. So y approaches negative infinity. Okay, I know that's a lot. Let's put it all together for just one practice problem. And on this one, I actually have an end point. So it has an arrow on this end, but it's got an end point right here, which is going to throw off the domain a little bit anyway. So I'm going to state all of those characteristics for this graph. Let's start off with, oh shoot, I already forgot everything. The vertex. The vertex is at +3, -3. And that is a minimum point because it's down at the bottom. The zeros are, oh goodness, let's just say that's a 0 because it's not quite, but 0 and then 1, 2, 3, 1, 2, 3.7. I'm just going to guesstimate here, 3.7. Okay. The axis of symmetry. Remember, that's the line that goes right down the middle of your graph. And it's always x equals, and then whatever the y-coordinate of your vertex is. Sorry, these are kind of off. I'm realizing I got the vertex wrong. The vertex is at 2, -3. So the axis of symmetry is x equals 2. It's the line that goes through 2. Okay, now let's do domain. And this one, typically the domain is all real numbers. And this one does go to the left forever. So it does go to -infinity, but it does not go right forever. The domain stops right here and doesn't go past it anymore. There are no more x values beyond that. So it's 1, 2, 3, 4, 5. So the domain only goes to 5. It does include the 5 because it's a closed circle there, so I'll do a bracket. The range is all the y values. Even though the graph stops here, it does continue on this side. So it still goes up forever, but it does not go down forever. It stops here and doesn't go below that. So that it doesn't go below -3. So the range is from -3 up, from -3 to infinity. I forget what's after that. Let's do interval of increase. This one is increasing right here. It goes up from 2 to 5. I'm going to include the 5 because it's an endpoint, but not the 2 because it's not increasing right there. And then for decreasing, it's decreasing all this time until here. That's when it stops decreasing. So as far as x values go, that's from -infinity up until 2. It's decreasing. Now let's do where it's positive and negative. So it's positive when it's above the x-axis, which is from -infinity up until 0. From then on, it's below the x-axis. So from -infinity to 0, then it's negative. So from 0 to whatever that was, 1, 2, 3.5, is that what we called it? No, 3.7. So from 0 to 3.7, it's positive. Oh, no, sorry. It's negative, and then it's positive again, from 3.7 to 5. So there are 2 positive intervals, here and here. And last, the end behavior. So as x approaches infinity, y approaches something, and as x approaches -infinity, y approaches something. On this side of the graph is as x approaches -infinity, y is going up, y approaches positive infinity. On this end of the graph, it actually just stops. So the end behavior is that point, the point 5, 6, or whatever that is. So I'm not even going to put that one because it's not like it's approaching anything interesting, it's just an endpoint. So all we need to worry about here is that left end behavior that goes up. All right, so those are some key characteristics of this graph here.